So hello again. Not totally, but a little bit of different topic. Build caching. Very powerful technology to accelerate all your builds, whether it's local builds or CI builds. So how does build caching work? It is not caching of dependencies. That's sometimes a misunderstanding. When we talk about build caching, we mean caching the outputs of a work unit. That work unit could be a Maven goal, or it could be a Gradle task site. So how does it work conceptually? Just in a nutshell. Basically, before a goal or a task is run, it will create a hash over the inputs that go into that goal or that task, and check with a cache whether something is already stored there. Something being the output of that. If it's there, it's used. If it's not there, it will do the work as usual. And at the end, either store the output in the cache or just move on and not store anything. So on the left-hand side, you can see that the work unit did work because it was not in the cache. It wrote it to the cache, and then the second build on the right-hand side, before it ran, it found it in the cache, so it didn't have to do the work, and it just used the output from the cache. So basically, you're saving the work that this task or this goal had to do. And this could be a task that takes 5 seconds. It could be a task that takes 2 hours. Compilation, testing, code generation, Java doc, all kinds of work that has inputs and outputs. Now, if you turn on build caching for Gradle or for Maven, you will likely notice that there are situations where you expect something to come from the cache, but it doesn't. But you're like, oh, but I didn't change anything in that area. What happened? Sometimes it could be that you're just wrong. Well, there did actually something change. But it could also be that there is some volatility in your inputs. Meaning those inputs change even though they don't impact the work that this task or this goal is doing. It could be a timestamp. It could be an absolute path, right? So let's say you run some code generation. It always adds the time it created that code to the Java doc header. And that will be always different. So always the inputs will be different to whoever consumes these source files. Same with absolute path. You run it on one machine and then on another machine or in another directory on the same machine. You have some absolute paths written somewhere in a resource file, or you pass them as system properties. Something has changed in the inputs and they will not use the output from the cache, right? Correctly. It shouldn't. But oftentimes it doesn't impact what that task is doing. So we want to get rid of that volatility. There are other cases, random code ordering. That's a common one, right? You generate code and it just uses whatever or no sorting at all. And sometimes methods are like this and sometimes like that. That creates different hashes, and so it can be reused from the cache. So what can we do to verify whether you have any volatility or not? Meaning, if you have no volatility, everything is taken from the cache. When you run the build twice, that build is considered fully cacheable. Right? So we run the build, we don't use anything from the cache, we run the build again under the same conditions, and then we check, did every task or goal that can consume something from the cache actually take the outputs from the cache that were put in there by the first build, right? So first build puts it there, second build consumes it. If it doesn't consume it, something has changed, even though we didn't expect it, because nothing should have changed. Now, this is a very error-prone process. Even it sounds very simple, right? But you have to make sure the cache is empty at first. You want to be sure you invoke exactly the same commands. You want to store the output of the first build, still have it available after the second build. All these things easily go wrong. I've seen it a lot of times. That's why part of the reason why we created these scripts is to make this process very reliable, make it very repeatable, also automated, or maybe that is also a consequence of the first two, and also keep that a productive process, right? So getting yourself to a productive engineering organization should itself be a productive process, right? So that's why we have these validation scripts in place that help you automate all these steps that you otherwise have to do manually. You don't have to be able to read this down here. This will give you an idea. So once you run that and you see, we have a build cache miss. So something is volatile here. You want to know more about it. Which one of those inputs has changed between the two builds? So you can, because once you understand, it's usually easy to fix. But if you don't understand it, it's really hard to find it, right? Using Develocity, you can use the build scan comparison, meaning you take the first build, the second build, you compare those two, and it tells you, in the second build, that input of that task or that goal changed. Right? And then you can go back and compare from the 2 runs what actually changed. And you see, the timestamp is different in the manifest. Okay, let me show this for real, and I hope you can see this. So it's very easy. You download the script. It's a public repo on GitHub. It's open source. Then you download the zip file that contains these scripts. There's really no magic in there, but it covers a lot of cases, old Maven versions, old Gradle versions, and so on. Then you download them, you go into that directory, and then you can invoke it. And what you see is already, when you invoke it, you provide the path to a GitHub repo. So you're not running this against anything local, which is a common source of errors, right? You run it against a GitHub repo, which is then checked out. It is run, the build, and then it's run again. And then we see, the second build, something was not taken from the cache. Everything should be taken from the cache on the second run. That is cacheable. All right, okay, let's follow the links. Let's go into comparison. It tells us, in this task, there was one property, one input that was different between the 2 builds. Okay, now that you know it was an entry in a resource file, you can go back to the command line. And when it ran the build, it stored the outputs of both builds. And now you can do a comparison of the actual content. Because in Develocity, we don't store the content of files, right? We were not a repo for like GitHub. We're only storing hashes and so on. And so then we can do a comparison of those 2 files from the 2 build runs. And we will see that it comes down. It's at the very end. You can see down here, in the end, it was a timestamp that was different. And once you know, it was this task that had a difference in this file, you can go away and fix it. And the different ways to fix it, you can either normalize it, remove it, or you just mark the task as not cacheable if you really need that input. But typically, dates in the manifest file are not used, for example, for running the tests. Right? So you would prefer to have the test be cacheable and ignore that timestamp. All right, so that is just to give you a feel for that. All right, so you fully optimize your build. It's fully cacheable. That is great, but you're not done. You will never be done. Because if you don't continuously invest into it, your build will regress. Right? It's like you write code, you write tests for it. You don't just run them when you write the code and then never again. Right? You keep running those tests to make sure the code you wrote is still functioning. And it's the same thing here. We need to have a setup where we constantly run these experiments and detect if something regresses. Now, we can use the same scripts that I showed. We can run them from CI. We can do a CI job in Jenkins, in GitHub Actions, or wherever, and we can run these experiments. We can use a special flag at the end, which means if there is something in the second build that was not taken from the cache, it will make that script fail with an error code, which makes the whole CI build fail, and then you can react to it as you react to every failed build. You send notifications, warnings all over the place, and then you react however you want to react to this. But this means the moment the change happens, you know about it, and you can react, and not a half year later when you realize your build times are up again because nothing's taken from the cache, or not everything that could be taken from the cache. So to make this very concrete, we sponsor like 25 or more open source projects. So we give them Gradle Enterprise or now Develocity for free, but we also help them optimize their builds. So now their builds are fully cacheable. But we want to be sure they stay cacheable, right? Because we invested all this time, and we also want them to get the most return. So we set up GitHub Actions that against all these projects from Apache and Spring and Kotlin and Micronaut. To run these, we run them every week, right? We don't run them on every change. I mean, in the end, it's still an open source project, but we do this once a week. And you see some failures. Some of these projects there are red. That means something happened during the week that now made these builds not be fully cacheable anymore. All right, and then we can go in there. We see the same summary that you saw before. Don't worry if you cannot read it. But it tells us again, something was not taken from the cache. We can follow the links and we can investigate. We can provide a fix, PR, they will integrate it into back to a fully cacheable build. That is now for us, we say business as usual. But that means the builds are always in the best possible state in terms of build caching. Now you could go even further. So instead of running that experiment on the same machine twice, you could also orchestrate 2 builds running on different machines. Okay, run this on this agent, then run the build on this agent. You get the 2 build scans. You feed that into the validation scripts by passing them both build scans. And again, if something's not taken from the cache in the second build, you fail that build. So this way you can even detect differences between different agents. Or a CI build and a local build, right? If you can simulate a developer's machine. You can go even one step further, and I think that's pretty cool, but still rather early, is you just run builds, right? And you have 1 million builds. And now you find all those builds or match those builds where you expect that the later run build takes all the outputs that were produced by the earlier run build. And if you see that something is not taken from the cache, then you again fail because you know you have a caching issue, right? And we actually did that with the Spring project. So we went over all the Spring builds from several months. We looked, same commit ID, no local changes, same JDK, and so on. And then we knew the second build, the newer build, has to take everything from the cache. But it wasn't the case. We found some build caching issues, right? There was an ASCII doc task that we identified just looking at builds, not running any experiments, where the second build should have taken, the ASCII doctor, the second build should have taken the output from what I was put in there before. So I think that is the most general way you can approach it, right? You don't even need to run experiments anymore, but you have the system find the pairs that where you expect that full cacheability, and if it's not there, you know something is not in the best state. So what I would like to encourage you to do is not only spend all this time making your build fully cacheable, which can be more work or less work depending on your build, but once you've invested all that time and you get all these benefits, keep it in that state by continuously detecting when something regresses. And just like you do with your tests, as I mentioned. Or to say it like Hans in his keynote, keep the knife sharp. That's it. Thank you very much.